Hi, welcome back. Our previous lesson was on how the changes in prices affect budget constraint. Today we are going to move on to non-linear budget constraint. So in our previous lessons, all of the constraints we have considered could be represented by a straight line. So remember that linear budget constraint arise from the assumption that the consumer is a price taker, implying that he can buy all he wants of a commodity at the going price. So we see a typical budget constraint represented by BO in this figure here. So although most budget constraints are linear, there are some that are not. So let's move on to an example of these cases. The first example we are going to look at is quantity rationing. So assume a government policy that allows only a certain quantity of a good to be bought for a particular period. So an example of this is if a government regulation limits the purchase of, say, cigarettes to 15 packs per month. Now, how does this regulation affect the budget constraint? So let's go back to a typical consumer called Ella, who consumes two good X and good Y. In this example, we are going to consider cigarettes as good X and rice as good Y. So if we assume that the price of good X is £5, and then the price of good Y, which is rice, is £10, and Ella's income is £100 per week, this information brings us to a budget constraint of 5x plus 10y being equal to 100. With this budget, let's look at what x-intercept is and y-intercept is. So we have a budget of 5x plus 10y being equal to 100. And in our previous lessons, we've talked extensively about how to get the x-intercept and the y-intercept. So with this information, the x-intercept is equal to 20 and the y-intercept is equal to 10. Now we can represent this on our graph here where our x-intercept is 20 and our y-intercept is 10. So this gives us a budget line called B1. The slope of this budget line is the ratio of the two prices. So that is minus price of good X divided by price of good Y, which is minus 5 divided by 10 equal to minus 0.5. So if we assume that under the rationing scheme, each individual receives 15 non-tradable coupons per month. So if Ella decides to spend this coupon on cigarettes, so for any amount of cigarettes Ella wants to buy, she must submit a coupon. So what this means is that the maximum amount of cigarettes Ella can buy per month has been restricted to 15 because of the 15 non-tradable coupon per month that the government gives Ella. This can be represented here on this graph. So for quantities of cigarettes less than 15, the budget constraint coincides with B1 and the slope is minus 0.5. Now we can see this on our graph that if Ella buys any amount of cigarettes less than 15, then she is in this region. So the two budget lines are going to coincide. So the budget line for when the coupon existed and when the coupon didn't exist are going to be the same for quantities of cigarettes less than 15. Now, if we represent the 15 amount of cigarettes as point K on our budget line, to the right of point K represented as this area, points on the old budget line B1 are no longer available to Ella. Now, they are not attainable because Ella has only 15 coupons. She cannot purchase any bundle to the right of K. Hence, her budget constraint with this new coupon scheme in place is kinged at B2. Ella's new budget constraint is now B2. And we see that amount of cigarette less than 15, she has a budget line that is equal to B1. And then at 15, which is the maximum she can buy under this new scheme, the budget line just becomes a vertical line. So this kinked red line here is Ella's new budget and is represented at B2. So like a typical budget constraint, B2 divides the bundle into those that are obtainable and those that are not obtainable. So those that are obtainable are those that are on B2 or below B2. So in this shaded area, given the scheme that exists, this is Eller's feasible set. So any bundle that is on B2 or below B2 in the shaded area is feasible and obtainable for Eller. And then any bundle that is above B2 in this shaded area is not attainable to Eller because of the scheme that exists. Unlike B1, B2 has two different slopes. So let's first look at the slope before point K. So before point K, the slope of B1 and the slope of B2, they coincide because you can see the two lines are coinciding in this area. So the slope of B2 before point K is minus 0.5. At point K, B2 now becomes a vertical line. Now along this vertical segment, the slope is infinite because under the rationing scheme, more than 15 packs of cigarette cannot be obtained at any price, which implies that the price of cigarette is infinite. So let's move on to the next example of nonlinear budget constraint, which is quantity discount. So remember that a typical budget constraint is linear only if the price per unit of each good is the same, regardless of the number of units purchased. So now let's assume that this is not the case and there's a quantity discounting system in place which causes the price per unit to decline with higher quantities. Let's consider a new consumer called Francis, who has an income of 100 per week and consumes two goods, bread and water. Now let's consider water as good X represented on the X-axis and bread as good Y represented on the Y-axis. If we consider the price of bread, which is Y in this case to be £1 per loaf, but then there's a twist with the price of good X. We consider the price of water to be P1 per gallon for the first 500 gallons per month, and then P2 per gallon for each of the next 250 gallons consumed during the month, and then P3 per gallon in excess of 750 gallons. If we add an additional assumption to be P1 being greater than P2 being greater than P3, so you can see that the price of water decreases after you have consumed a certain unit in the month. So let Francis' budget constraint be represented by this figure that we have here. So the first thing we are going to do is calculate the y-intercept. The y-intercept is going to be 100 because the income that Francis gets is £100 per month and the price of good Y is £1 per loaf. For the intercept for water is going to be slightly different than what we typically see in our previous lesson. For the first 500 gallons, the price of good X is P1. So the slope of the curve up to point B is going to be minus the price of good X divided by the price of good Y, which is going to be minus P1 because the price of good X is P1 and the price of good Y is 1, so it's just going to be minus P1. Now, after consuming 250 extra units, price of good X now reduces to P2 per gallon. Between point B and C, the slope of this curve is now minus the price of good X, which is P2, divided by the price of good Y, which is still 1. So the slope now reduces to minus P2. Now, if we look at the extra unit, the price of water reduces to P3. So the slope this curve is now going to be minus Px over Py. The price of X is now P3 and the price of Y is still the same. So we have the slope as P3. What we see here is that the budget constraint is a kink line that is bowed inwards towards the origin. So when the price per unit of a commodity varies with the number of units purchased, the budget line is no longer a straight line. The changes in the price are reflected in the slope of the budget line, which leads to a non-linear budget line. This is all that we have on our lesson on non-linear budget constraint. Next lesson will be on consumer optimization, looking at the interior solution. If you enjoyed today's lesson, consider subscribing. Thank you.